Today on the Rockabilly Arts, we are making a drive-by-wire 103mm throttle body adapter for a 4150 flange. Why? Because we dumb. Stay tuned. Look, I know it has been like years since I made a video that was, actually working on my car. And for those who may remember, about 5.5 years ago, I took my car apart thinking, oh, it's going to be simple. I'm just going to swap in this fuel injection system. That didn't work. Now my car is in a bazillion pieces and I'm having to make really weird, dumb parts that don't exist. So, yeah, so all the why will kind of make sense over time as, I make more videos, hopefully. But yeah, today I'm making a throttle body adapter. So I have a 103mm Nick Williams drive-by-wire throttle body, which doesn't make a lot of sense on a 72 Cadillac. But again, when I talk about my steering wheel, this will all suddenly make a lot more sense. But only one company really makes the adapter I want, and they quit making it. Like Holley used to make an adapter that would fit it. They still make one that will take up to, I think, a 92 or 95mm. But yeah, when you get into the 103. So I think the one that's on the machine right now, I don't know if you can see that, is failure number 4 or 5. Yeah, this has been an expensive process of trying to create new parts, but I'm learning, and that's fun. And also, I don't think you guys have seen this yet, but this is my new machine. So the old CNC machine that I was carving signs on did really well, loved it, but I was always a little irritated by the capacity of it. And when the Shapeoko 5 came out, or Shapeoko 5 Pro, I guess, came out, they had a 4-foot by 4-foot option. So then I realized I could make signs using a full half sheet of plywood. So bought this and did really well on signs, and then got really busy. A whole lot of life happened. And so I recently converted it to do aluminum. And so just upgraded to a 2.2, I have no spatial perception apparently, 2.2 kilowatt spindle, water cooled, did some offset blocks to raise the Z up 30mm, offset the gantry to the front so that I could, and I can't see what I'm doing. So if I needed to, I could overhang the front, and then I just built this enclosure over here to keep the chips in, because I did spend a good bit of time vacuuming chips this morning so that I could start over. And yeah, it's a mess. I mean, like a big old hairy mess when you start making chips, and when you have 4 or 5 6 by 6.5 inch blocks of aluminum that get turned into a much smaller piece, chips fly everywhere. So I'm going to walk you through the whole process, and I'm not going to show you what I did in Fusion, but if you want me to, leave a comment in the below, and just I can walk through how I designed it. Literally, I took the throttle body with a set of calipers and some bolts through it, and a gasket for the 4150, and measured everything. 3D printed a couple of versions of them to make sure they worked like I wanted. And the reason I'm doing them this way is so that I can have a vacuum port and then 2 NPT holes for a mass airflow sensor and an intake air temperature sensor, so I don't have to tap into the intake itself. So, all right, what we're gonna do first is I'm gonna break down the piece that's on there right now and put the fixed, you know what, I can actually just bring this over. Sorry about that weird cut. Yeah, so this is a Saunders machine plate, in standard with these are some soft jaws I made that I've screwed up royal, and you kind of see the part, the top side worked out really well, but I'm off by 0.125 this way, and I'm off by a very little bit around these edges, but it's just wrong. And so when I went to pull it back up in Fusion, I figured out that I had the coordinate system wrong. So first thing I'm gonna do is swap these back to the fixed jaws, and then mount up a fresh block, and we're gonna surface that. And once it's surfaced, I can flip it over in the hard jaws and start machining the top. So I will stop periodically and kind of talk about what I'm doing, but yeah, that's what we're gonna doing. And yeah, hopefully I can make an actual part, and I'll just pop random shit up on the screen to tell you what is what. So let's do this. we're gonna get this in here. And so right now it's kind of free floating. One of the cool things about these Saunders jaws is, one, they're 100 times cheaper than, you know, a really nice set of, like, oh, I forgot the name of the brand, but yeah, way cheaper than, you know, kind of a normal mill vise, and they, you know, very low profile. Obviously got a hard edge over here that I mount to, but these holes are eccentric. So when I start tightening this down, it pushes this forward to lock everything in place. So what I'm gonna do is I'm just gonna kind of snug it. They have some anti-seize between here and this kind of in this layer where this sits on. So we'll just snug it a little bit. Then get out ye old persuader and give it a couple of taps, and we'll love tap there. A little more nice and even, and then give it the old squeegee. In technical terms, I'm putting about 1 ugga dugga worth of pressure on that. Alright, what we're going to do, and you know, I'm just going to explain what I'm going to do. I orient these pieces off the middle, so before I cut it. And I know that it's 6 inches across and 6 and 9/32 wide. So I actually programmed it to be like 6.625, so that'll start on the edge. And I will just, I'm gonna zero off this corner, so I'll do, you know, yeah, X, Y, Z this way. And then because I know the dimensions of it, I'll bring this in 3 inches, set a 0, and I'll bring this over 6.269, which should give me dead center, because we know this is a fixed distance. And then I'm gonna load up the a 3-flute Lakeshore Carbide 3/8 end mill in the big spindle of doom here, and just let it eat. So I don't need to, I'm just going to park the camera somewhere so you can watch it run. But yeah, the reason I'm doing this, because this is drawn bar, and so this is not perfectly flat. And since, one, I'm making a gasket mating surface, I want this to be flat. But two, I want it to sit flat in the vise, and at least it'll be referenced to this plate through the vise. So when I go to mill it, all the dimensions are reasonably accurate to where they're supposed to be. So that's why I'm going to mill this first. I'll flip it over, set the Z again, start in the middle, and then we'll start running all the different processes and do all that stuff. So probably the last time I talk for a little while. You probably noticed, or you maybe didn't, there's a little black hose on there, and it's an air nozzle, and I'm pointing it directly at it. And let me explain why real quick. So, also I'm sweating like crazy, because when I built my enclosure, I didn't even think about the fact that the air conditioning duct in here just dumps straight in there. So yeah, if I open the door, it's nice and cool inside the enclosure, and the rest of it sucks. Alright, this is a single flute. Alright, this was made by Cody CNC, or Cadence Manufacturing, for me, oddly enough. But this is a Jenny, a 3/8 Jenny, Jenny, I think is what he calls it. And the single flute does a lot of chip removal, and doesn't really ever get stuck because it has all of these flutes to be able to just evacuate the chips. This is from Lakeshore Carbide. It's a 3 flute, so 1, 2, 3. And the reason why I'm blasting air right at that point is so that I can get the chips out of the way. Because, like, when you're doing the math, and I might even throw the formula up on here. Chris, remember, throw the formula up on the screen. I will show you like what the chip removal rate. So I spend these at just over 18,000 RPM, both of them. But I need to move this one almost 3 times faster to get the same evacuation out of this. And what you're trying to do is, one, keep it from welding to the end, But two, you're taking the heat out of the piece, right? So like as it's carving away at, you know, the material, you're taking that heat, you're chucking it off to the side, and then you're blowing it all out of the way with the, because I'm not using, you know, alcohol or anything like that. So like if you saw that last bit, when it first started off, that was running 18,000 RPM at 150 inches per minute, but my depth of cut was too deep. And so it was just hogging through it. It was very unhappy about it. So I had to slow it down a ton and adjust the amount of air I was throwing at it. So I'm now going to put this one back in. I do have to swap collets constantly because this takes a 3/8, the locating pin takes a 1/4, the thread miller takes a, you know, 3/16, the, you know, the little small hole takes an 1/8 collet. These are all ER20. So yeah, we're about to throw this one back in the machine and just going to let it cook. So this should be fun. I'm hoping I've solved a lot of my other problems I've made for myself over the last 4 attempts at making this. But yeah, this bad boy right here. Let's see how she do. Remember what I was saying about it makes a mess? Like, look at all these chips, man. All these chips. Shouldn't do this. It's sharp as shit. So, yeah. Aluminum. Who knew? There's a little 3 flute. Now, what you just watched was there was a adaptive clearing path first, and then 2 contour passes from the inside down. What I could have done on this top surface, I did too much of a step over, but you know, well, you'll see it in a minute. It looks gorgeous. All right, this next part is the part that makes me nervous. So up first, we're going to use there's just a ball nose end mill that's going to do the inside scalloping. That'll smooth out the inside, and then after that, we're going to switch over to a quarter inch end mill, do the outside holes, switch to an 1/8 inch to do the inside holes, and then the thread mill. I've only done this once, okay? Like, this only worked one time. Once. So I'm a little nervous. Hopefully this actually works twice, because I didn't change anything, but you never know. Shit goes wrong all the time. And at, you know, $40 a pop per piece of aluminum, I've messed up quite a fair amount so far. But yeah, like, the finish on this is going well so far. So as a statement of historical record, no way looking forward perspectives kind of thing, like, up until this moment, things have gone well. So I'm not jinxing myself because I'm not talking about anything happening in the future, just saying how it's gone so far. So yeah, let's do more stuff. You ever have one of those moments when you think, man, I should have just kept my damn mouth shut? Yeah, so I just mentioned, you know, like, oh, everything has been going great. And I went to change the bit, and the machine retracted all the way to the back and jackknifed. So, like, I think it just had a bunch of material stuck or something, and it couldn't reset all the way back and hit the switches on them. So, had to take the sides off, and in a rare display of forward thinking, when I built the enclosure, I put threaded inserts all the way around so I could take the sides off as needed, and I vacuumed all of it out and, you know, blew it all off with some air and was able to rehome the machine, thankfully. And it just did the scalloping bit on the inside, and so that looked accurate, but now we're up to the threading part that I've been kind of dreading. So let's see what happens. Now we're ready to flip this bad boy over. So far, you know, I'm not even gonna say it. Just look, behold, enjoy. Yes, look at it in its glory, with holes, threaded holes that work. All right, what we're gonna do now is these are soft jaws. Basically, they're sacrificial. So I just went in and cleaned all this up and put these new ones on. I set the XY here, so Y, X, Z. So when these mill, it's going to create a relief here and here that this will sit in just like that. So it'll basically mirror this, so it'll locate that. I'll find the Z off the top of this part, and that'll be my new coordinate system. I've literally done this one time, and it didn't work. Hopefully this is a better chance and like things work like they're supposed to, but we'll see. Yeah, I'm just going to cut these with a 0 flute 1/4 inch end mill, throw a bunch of air on it, and see if it fits. Look at it. Oh, it's pretty. Oh, it's pretty. Look at that. Well, the flip worked. There's a little slight, like, that couldn't be the thickness of a piece of paper offset. I could feel maybe a little one on the back side, but it's consistent, so I don't really know what happened there, but it worked. It worked. I am super pleased with this. And check out how that like inner contour turned out, like little scallop action. So this is what the ball nose end mill, that is a, what is that, a Nomad 202, which is a 1/4 inch 3 flute. And so when I relieved this part, right, so this is the bottom that attaches the carburetor, so this is the size of the carburetor hole, or the intake hole. You know, this is a round hole, this is a not square, it's actually a slight rectangle, and so you have to loft from here to here, but then it creates kind of a multi-dimensional thing, right? So it comes in this way, but it goes out that way. So that was kind of a pain to do in Fusion, but it worked, and my God, that's an actual usable piece, finally, after so many attempts. And I am happy as can be right now. So yeah, that's it. If anybody's wondering, I get most of my recipes for speeds and feeds. I start on provencut.com. Those guys are amazing. I have no relation to them whatsoever. I've just been using their stuff forever. And like, it's a good starting point. Like if you just take their speeds and feeds and slow it down like 20%, you can just kind of listen for it and feel how it goes. Yeah, man, I am happy right now. This means I can move on to the next thing, which is my steering column adapter, and that's going to take a lot more exposition to explain why that what happens when neurodivergent people have, you know, toys at their disposal. So anyways, yeah, I'm hoping to start making videos again, and you know, hope you like them. If there's anything you want to see or have any questions, feel free to hit me up. And as usual, remember, drive fast, take chances, and safety third. Good night.